Yeah. This morning I wanted to do small revision on integration and we'll consider that is definite integrals, two of us. Then we'll consider differential equation, definite integral. Yeah, if I may recall, in our last class, we did a lot of definite integrals, two of us. Yeah. So this morning, I will just be brief on definite integral, then we move to differential equation. We are going to solve differential equation using two methods. One, separation of variables and integrating factors. Is that clear? Okay. So we know very well that definite integrals are of this form, a running to b of x dx. Two of us. You know, I mentioned it to you the other time in our last class that definite integrals, they are integrals you integrate to obtain what values. Two of us. Exactly. So if we integrate this integral, it means we are going to have what? X raised to the power of 1 plus 1 all over 1 plus 1, 2 of us, at a to what? B. So this implies that this is x raised to the power 2 all over 2 at a to what? B. Isn't it? Okay, so now what we need to do, we have to substitute the lower limit from the upper limits. Amen? Amen. Okay, so it means anywhere we see x, we write b square all over 2 minus what? A square all over 2. You agree with me, right? So let's move further to consider examples of this form. Assuming you are asked to evaluate integral 0 to infinity t exponential minus open bracket alpha plus beta times t dt. Yeah, you know very well that integrals like this, you don't need a prophet to tell you. Why? Because this integral, before you be able to integrate this function, it means we are going to use what is called integration by part, two of us. Because we have how many functions? Two functions. We have one here, we also have one here. Two of us. But they are definite integrals, isn't it? Okay, so what we need to do here is we write solution. It means we now say using by parts, right? Using by parts. So that is, the formula is u dv equals to uv minus integral v du. Amen? Okay. So, if you can see what I am saying, if you can see what I am saying, this implies that from here, we now say let u be equals to what? T. And dv, this dv be equals to what? Exponential minus open bracket alpha plus beta times t, right? dt. equals to exponential minus open bracket t dt, right? So this implies that we have to differentiate this function with respect to t. So if we differentiate this function with respect to t, we are going to have u all over what t is equals to what? 1. What is that? Amen? Okay. So if you can see what I am saying, you don't need a prophet to tell you. So this is du is equals to dt. Then we are to integrate this with respect to what? We integrate both sides. We integrate the v and this exponential dt, two of us. So if you integrate the v, what is supposed to have? You are supposed to have v, two of us. So the left hand side will be v, then equals to, if you integrate this, you are going to have minus exponential open bracket alpha plus beta t all over what? Alpha plus beta. You know, I told you that it is not necessary for you to put plus. Why? Because we are using integration by parts, and at the same time, we are talking about definite integrals, right? Okay. So if you can see what I'm saying, we have to substitute this here. So here will now be integral 0 to infinity t exponential minus open bracket alpha plus beta t dt, right? Now be equals to, excuse me, now be equals to, yeah. Okay, yeah. Okay, yeah. So, at this point, what is our ordinary u? T, right?
Yes, sir.
Now, what is our ordinary v? Minus exponential. Okay, so here we are going to write minus first, then write t exponential minus open bracket alpha plus beta t all over beta plus what? Alpha plus what? Beta, right? Okay? So, let me just write it up now. So that our v is equals to t. Then our v, ordinary v is equals to exponential minus plus beta t all over alpha plus beta, right? Okay. Yeah. So if you can see what I am saying, what do you have here? Minus, right? Minus integral. Oh, sorry. This is what definite integral running from 0 to what? Infinity, right? So we have to indicate as, because we have integrated this, right? 0 to infinity minus integral 0 to infinity. What is our ordinary v? Minus, right? Minus exponential minus open brackets plus t all over what? Alpha plus two of us. Okay. So I think we have to shift this chair this way. Please. Let's shift it this way. Okay, yeah. So if you can see what I am saying, you don't need a prophet to tell you. Two of us. Sorry, this is the T.
No, sir, down, yes.
Our U. The U.
Is the T.
The T times the T. Two of us. Okay. So, yeah. So what we need to do here is for us to substitute, subtract the lower limit from the upper limit, right? So if you can see what I am saying, so here will be minus, here will be infinity. Open bracket, infinity times exponential, open bracket, alpha plus beta times infinity, all over alpha plus beta, right? Then minus again, two of us, minus, here we got 0, 0 exponential, minus open bracket alpha plus beta, t, all over beta plus alpha plus beta, then minus the integral 0 to what? Infinity. But if you can see what I am saying, this times this, so we can write plus here, right? So here will now be exponential minus open bracket alpha times t, the t all over alpha plus beta, right? Yeah. I'm doing this for the sake of balance. If not, it's not necessary because this, yeah, 0, true of us. This infinity will give it 0. This 0, if you use 0 to multiply, sorry, here is supposed to be 0. True of us. So it will give you 0. So you can now see that. Here, let's have it here. Yeah. So you can now see that we have to integrate only this function. True of us. But something is constant here. What is constant here? Yes, 1 all over alpha plus beta. True of us. So we factor it out. So this is equals to 1 all over alpha plus beta integral 0 to what? Infinity, right? So we are going to have exponential minus open brackets t. Amen? That be so. So that you people will have long life and prosperity. Amen. If we integrate these idioms, what is supposed to have? It means we have 1 all over alpha plus beta, open brackets, minus exponential alpha plus beta t, all over alpha plus beta at 0 to what? Infinity. It's not necessary. You want to do it like this, or you do bracket. It's okay. So, yeah. So it means here will now be 1 all over alpha plus beta. True of us. Open bracket. Let's substitute in. If we substitute in, we are going to have minus exponential minus open bracket alpha plus beta times 0 all over alpha plus what? Beta, right? Sorry, infinity. Sorry, yeah. Then here is minus open bracket minus exponential minus alpha plus beta times 0. Then all over what? Alpha plus beta. Here, close the bracket, then close the bracket. True of us. Okay. So, if you can see what I am saying, here is 0, right? Because of this infinity.
Yes, sir.
True or false?
True.
So here will be alpha plus beta, open bracket 0, minus times minus, plus here is what? 1. Because exponential 0 all over alpha plus beta, right?
No.
True or false?
True.
So here we're going to give us equals to 1 all over alpha plus beta. Open bracket, here is 0, so here is 1 all over alpha plus beta. Then this is equals to 1 all over alpha plus beta.
Equal 2.
All square.
Yes, sir.
Yeah.
Yes, sir.
True or false?
True, sir.
Any question? Any question? Any question? No question? We can proceed, right? So let's move further to consider the differential equation.
Yes, sir.
I want to film. Yeah.
Go, sir. On this side, sir. This DT, sir.
Yeah.
I see we didn't include it in the song.
Where?
That DT before we integrate the exam.
Yeah.
Yes, sir.
How?
Like where did DT move?
Hmm?
Where did DT move? I see you are not carrying it alone.
Why will you carry it along when you have integrated?
Okay, after.
It's this one that is making you to integrate now, just like before you want to move a car, there must be fuel, true or false?
Normal.
Yeah? Where are you people? So, even differential equations we did a lot, two of us, last week. So today we are going to use the two methods, using separation of variable and integrating factor. So please take note of this, very important, because definitely see them. Probably, sorry. Where are you guys?
We are done.
Huh?
Almost done.
So no question, right?
No, sir.
Okay. Yeah. Let's proceed. Let us proceed. You know, the other day, I tried to make us understand, to give examples of differential equations and also classify them. Two of us. I told you that if we have dy all over dx equals to, let me say, 0. This is the first order differential equation, true or false? Then I also mentioned that if we have d square y all over x squared plus dy all over dx plus y equals 0. This is the second order ordinary differential equation, true or false? Then we were taught how to classify them into degree, true or false, and order, true or false. So today we are going to use separation of variable to solve first order OD, ordinary differential equation. So separation of variable, this is one of the methods that we want to use. Technique. Okay. Yeah. We want to use separation of variable techniques, right? Yes, sir. Okay. Assuming you are asked to solve the differential equation. We have dy all over dx equals to 7x. It's simple as ABC. Just listen because it will do you good. Is that clear? So let's look at it together. This is a first order OD, ordinary differential equation. So if, assuming you are asked to solve, it's simple as ABC, using separation of what? Variable method. The separation of variable method is this. Just like you are trying to separate, like, okay, let's look at it this way. Since we have A, B, C, your class, right? Okay, D, right? So, if you are gathered in a particular domain, they may say, I have separate yourself. It means you can easily separate yourself according to your what classes. True or false? Yes, so that approach is what? Separation of what? Variables. Because we are trying to, you people are trying to separate A, B, and C. So the same thing is applicable here. Is that clear? So now, look at this differential equation. Let's write solution, right? Our dy all over x is equal to 7x, right? So now, look at this differential equation. You can now see that in the left hand side, we have dy all over dx equals to what? 7x, true or false? So before one can be able to use separation of variable, it means the ones having y must be on one side, then the ones having x must be on one side. Is that clear? So just see with me that in the left hand side we have dy over dx, true or false? So before we can use separation of variable, we have to separate this dx. Thank you. Yeah. So if we cross multiply, note that there is an invisible one here. True or false? So if we cross multiply, it means 1 times dy. Then 7x times 7x dx. Amen? Amen? So now, at this point, you are seeing dy, you are seeing dx. So you don't need a prophet to tell you. When you come across ordinary differential equation like this, you don't need a prophet to tell you. What you need to do, because of this dy and dx, you have to what? Integrate. So integrating what? Both sides. Integrating both sides. Okay, integrating both sides, right? Okay. So to satisfy this statement, it means this is what it means. Integral dy equals integral 7x dx. Amen? So now, if we integrate dy, what are you supposed to have? Y plus a constant. So y plus a1. Amen? Then equals to, if you integrate 7x dx, you are supposed to have 7x squared all over 2, right? 2 plus k2. You understand? Yeah. So if you can see what I am saying, this means our y is equals to 7x squared all over 2 plus k2 minus k1. Amen? Okay. So now what we need to do, we can write that if we set k2 minus k1 equals to k, amen? So our y is equals to 7x squared all over 2 plus k. Yeah, I'm doing it in this form because I know some of you go and study, open one textbook, and you come across it. Maybe I just write only this one. You want to say Kai, but the way Mr. taught us, it's not like this now. You want to be confused. Don't get confused. Let me just open your eyes. You are integrating left hand side. So you are supposed to have a constant, true or false? So by the time you integrate the right hand side, you are supposed to have another constant. But since we are asked to find this general solution, find this. Is that clear? So you have to use only one variable as the constant. But if you say you just want to treat, we are supposed to stop here. It means one can just conclude by saying y is equal to what? 7x squared all over 2 plus what? Okay, you are also right. Is that clear? But I'm just trying to let you know that there are some textbooks when you go. If you go and open them, definitely you will see things like this out here. So don't get confused. Is that clear? Yes, okay. So, do you understand? Yeah. So we can proceed further to solve more examples, right? Okay. Okay. Okay, another question says, determine the general solution. Example. Determine the general solution. General solution of x dy all over dx is equals to 2 minus 4x squared. Please copy it fast so that we know. Okay. Yeah. So let's look at this one again. It's simple as ABC. So we are doing it together, right? Let's start. Solution, right? X dy all over dx is equals to what? 2 minus 4x squared, right? So what are we going to do? We are solving together. Yes, how long? Cross multiply, right? So note that there is invisible one here. So here will be x dy equals to 2 minus 4x squared times what? Yes. What are you going to do again?
Integration on both sides.
No. Thank you, yes. We divide both sides by what? X, right? So if we divide both sides by x, we are going to have dy equals to 2 minus 4x squared over x dx, right? So what else? We integrate both sides, right? So if we integrate it, our dy is equals to integral 2 minus 4x squared over x dx. True or false? Okay, if you can see what I am saying, this is integral dy is equals to integral 2 all over x minus 4x squared all over x d what? Yes, right? True or false? Yes. So if you can see what I am saying, this is the same as integral dy is equals to open bracket 2 all over x minus 4x dx. Then this is the same as integral dy is equals to integral 2 1 all over x dx minus 4 integral x dx. True or false? True. Can I clean this side? Yes. Okay. So, if you can see what I am saying, this is if we integrate this, we are going to have y equals to what? 2 in x minus 4x squared all over 2 plus g. True or false? Then this to cancel this 2, right? Okay, y is equals to 2 in x minus 2x squared plus g. This is the general solution. Any question, please? Yeah, ask your question. Where?
From this dy equals to integral of dy equals to the constant of
Yeah.
yes.
How do we arrive at 2? Constant 2. Look at it now. If we have 2 all over x, this is same as 2 times 1 all over x now.
yes.
True or false? No question? Okay, let's consider my example. find the particular solution find a particular solution of the differential equation of the differential equation 5 dy all over dx plus 2x equals to 3 given the boundary condition, given the boundary conditions y equals to 1 over 2 all over 5 when x equals to 2. It's simple as ABC. Okay, let us look at this. Then we consider integrating factors. Let's write solution. Solution. Our differential equation is 5 dy all over what? Dx plus 2x equals what? 3. Right, we are solving it together. So, since it is a first order differential equation, what do we do? Like terms, right? So, 5 dy all over dx is equals to 3 minus 2x. True or false? Then what else? Cross multiplication, right? So 5 dy is equals to 3 minus 2x dx and dx. True or false? Then what else again? By what? 5. Thank you. So here will now be dy is equals to 3 minus 2x all over 5 open bracket dx. Amen? Amen. So what do we do now?
Integrate both sides.
Integrate both sides, right? So if we integrate both sides, it means we are going to have integral dy is equals to integral 3 all over 5 dx, true or false? Minus integral 2x dx. Then this is the same thing as dy is equals to 3 all over 5 integral dx. True or false? True or false? True. Okay. Then minus 2 integral x dx. Amen. Okay. So if we integrate this, we are going to have to obtain our general solution. Will now be what? Y is equals to what? 3 all over 5x minus 2x squared all over 2 plus k. True or false? Then our y is equals to 3 all over 5x minus x squared plus k. Isn't it? So this is our general solution. You know, sometimes they write general solution in this form y of g. if you see the textbook of this form, it means this solution means what? General solution. Is that clear? Huh? Sometimes you will see y of c. This means it is a complementary solution. Take note. Is that clear? When you get to HND, you will come across complementary solutions. Sometimes you will add both complementary and particular solution to have this. It's okay. Yeah. So now we have boundary conditions, two of us. That y equals to 1 over 5 when x equals to 2. So they said we should find a particular solution, two of us. So how can we find a particular solution? We have gotten our general solution. So it's from the general solution using the boundary condition to obtain our what? Particular solution. It means we are going to eliminate this constant. Yeah, you want to ask question? Yeah?
Yes, okay.
Oh, sorry, yeah. Sorry, we made a mistake here. Thank you. It's supposed to be yes. So here is supposed to be yes. Not just. So it means we are supposed to have 5 here, which is 10. Two of us. So here is supposed to be 5. Thank you. Yeah. What is the problem? Okay, no. Yes. Thank you. Okay. Yeah. Thank you very much. So that is mathematics for you. Okay. So yeah, we need to substitute for with this, right? So when where y equals to 1 whole number, yeah. Thank you. Thank you very much. I don't know whether we need to.
I wish to know that.
Huh? Huh? No. I have.
You can't no longer. How to ship it in? James, someone ship it in. I know this can match my market.
Aya. Let's take that this is our work. Guys. This is mathematics. It's mathematics now, you don't know. Yeah.
Yes.
Amen.
Amen.
So this is 2 all over 5 and x equals to what? 2, right? Huh?
Yes, sir.
X equals to 2, right?
Yes, sir.
Okay. So it means anywhere we see y, we write what?
1.
Okay. So from here is 1 whole number 2 all over 5 equals to 3 all over 5 times 2, right? Minus 2 squared all over 5 plus what? Okay. 2 of us. Right?
Yes, sir.
Okay. This times this 5 plus this 7 all over 5 equals to this times this 6 all over 5 minus 4 all over 5 plus k, right? So here is 7 all over 5 equals to 6 minus 4 all over 5 plus k. True of us. So this is
2 over 5.
right? But I want to do something. I want to do something. Alright. I want to do something. This is the same thing as. Okay. This is the same thing as. Okay, let's proceed. Let's proceed.